Hi guys, today we are going to discuss about the Varignon's principle and prove Varignon's theorem. Well, this theorem is used to solve numericals based on the composition of coplanar non-current force systems. The theorem states that if a number of coplanar forces are acting simultaneously on a particle, then the algebraic sum of the moments of all the forces about a point will be equal to the moment of the resultant force about the same point. Basically, it means that the moment of the resultant force about a point will be equal to the algebraic sum of the moments of all the individual forces which are acting about the same point.
Now, coming to the proof. Let us consider the following diagram. Here, F1 and F2 are two forces which are acting on the point O1. Let F1 make an angle θ1 and F2 make an angle θ2 with the x-axis. Let F be the resultant of these forces. This will make an angle θ with the x-axis. Now, consider a point O on the y-axis. Let us draw the perpendicular lines from O to all the three forces. Now, these angles will be same. Hence, this will make an angle of θ1, this will make an angle of θ, and this will make an angle θ2. Let D1, D and D2 be the perpendicular distance of the force F1, F and F2 respectively from the point O. Now, let us consider the moment of force F about O. We know that moment is given as the product of force into the perpendicular distance. Hence, from the figure, we can note that moment M is equal to magnitude of the force, that is F, into the perpendicular distance, that is D. Now, let us consider the triangle OFO1. Here, we can see that cos theta can be given as adjacent by hypotenuse. Hence, we can write cos theta is equal to D divided by OO1. Hence, from this, we can write D is equal to OO1 cos theta. Now, substituting the value of D in this equation, we have M is equal to F into OO1 cos theta, or we can write this as OO1 into F cos theta. Now, F cos theta is the horizontal component, that is the x-axis component of the force F. Hence, this can be written as moment M is equal to OO1 into Fx. Let us name this equation 1. Similarly, by using this principle, the moment of force F1 about the point O is given as the magnitude of force F1 into the perpendicular distance d1. Now, considering the triangle OEO1, we can write d1 as OO1 cos theta. Hence, the moment is written as OO1 into F1 cos theta 1. Now, F1 cos theta 1 is nothing but the horizontal component of the force F1. Hence, this can be written as M1 is equal to OO1 into Fx1. Similarly, the moment of force F2 about O1 is given as M2 is equal to the magnitude F2 into the perpendicular distance d2. From the triangle, we can write d2 as OO1 cos theta 2. Hence, the moment is given as OO1 into F2 cos theta 2. Now, this is the horizontal component of the force F2. Hence, this is written as M2 is equal to OO1 into Fx2. Let this be equation number 3. Now, adding equation 2 and 3, we have M1 plus M2 is equal to OO1 into Fx1 plus OO1 into Fx2. Now, this is nothing but the horizontal component of the resultant force. Hence, this can be written as OO1 into Fx. From equation 1, we know that the moment of the force F about O, M, is given as OO1 into Fx. Hence, from this, we can write that M1 plus M2 is equal to M.
Hence, we can see that moment of the resultant force F about O is equal to the moment of the force F1 about O plus the moment of the force F2 about O. Hence, the Varignon theorem is proved. Thank you.
Wow, that's That's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.